SBOM, SBOM, you're the SBOM. Oh, hi, I didn't see you there. I was just practicing for the Tom Jones concert later. Up next, we have Allan Friedman and Jens Wiesner talking about SBOM and advisories. So if you're interested, curious about software bill of materials, if you want to learn more about how those relate to your organization, how they are currently being conducted in companies around the world, then tune into that one and come to the Discord chat for a conversation with the panelists, with the discussants. We'll be there waiting for you. Discord and the I Am The Cavalry track. See you there.
This talk is about your critical software and is it not vulnerable? It dives into CSAF, VEX, and SBOM and the future of advisories. I'm Jens Wiesner, and with me is Allan Friedman. So why should you attend this talk? Because we need different approaches. We need new approaches, thinking about vulnerabilities, and you will be asked. Customers will be coming to you and ask about how to secure your supply chain. And there are some new things in this talk. It's not SBOM, because when Allan is with me on the talk, it's about SBOM. And this time we talk about VEX, something different, something about communicating that your product is not vulnerable. And we try to draw a bigger picture how to do this on a better automated way. And there's a policy version of this talk, because knowing Allan, there are a lot of changes coming, and supply chain security at the moment is not good. It's not working properly, and from my experience, it's next to impossible to really completely secure the supply chain. And with the Executive Order 14028 and the European new legislative framework, there's a lot of change coming. And by the way, we are from the government, and we're here to help you. So I'm from the German Federal Office for Information Security. We are more or less in the role of CISA in Germany. We are defensive only, historically defending or securing governmental networks. And since 2015, we are also responsible for securing critical infrastructures in Germany. And Allan, well...
And I've been at NTIA for 6 years. And part of what we do at the Department of Commerce is identify areas where we believe we can help the broader InfoSec community help itself. So we've tackled issues like vulnerability disclosure, field upgradability of IoT, and perhaps most noteworthy recently, software bill of materials, or SBOM. And we're going to talk a lot more about that. But essentially, our role in government is to help the community organize, because we know that these solutions aren't things that the government can unilaterally push. There needs to be strong, effective partnerships between companies, government, and of course, hackers. So a lot of what we're going to be talking about today boils down to vulnerabilities, right? And of course, we all know the vulnerabilities that have their own logo and their own theme song and their own breakfast cereal. But at the end of the day, this is the table stakes for proper security, right? Known vulnerabilities should be the easiest part of security. And yet, in many ways, it's not. A lot of these vulnerabilities, many organizations, whether they're making software or selling products or just running things, don't have a quick and easy way of answering what should be a very simple question. Am I affected? We don't have a clear answer to that today. Now, we're going to know a lot more about potential vulnerabilities with software bill of materials, or SBOM. That's going to really change our visibility into a lot of that. That's one of the key points behind SBOM. But wait, hang on a second. Jens said that everyone knows about SBOM, but I'm not sure everyone does. So we're going to take just a quick moment and sort of review, hey, what the heck is this SBOM that folks have been talking about for a while? So first, not a new idea, been around for a while. Just the last 3 years, NTIA has worked to bring together a large, diverse global community to help bring folks together to find out what it means and how we can implement it. And at its core, an SBOM is very simple. It's a dependency graph, right? We don't write all of our software from scratch. We use other people's software. SBOM is just a way to capture that. So my Acme application or my Acme appliance, if we're doing an embedded device, in our toy example, has exactly 2 dependencies, top-level dependencies, bingo buffer and Bob's browser. Bob's browser, in turn, depends on Carol's compression engine. And that's really all this is. It's not that complicated. Now, implementation is always a little tricky, but a couple of things. For each of these software components, we don't need that much information. Right? What's the supplier? What's the component? What's the version? What are some of the identifiers, right? Does it have a CPE or a Perl? And then where did this data come from? And the other thing I want to flag is that we try to be very explicit about known unknowns. So, for example, we know that Carol's compression engine doesn't have any further dependencies. We simply don't know if bingo buffer has dependencies or not, and that's okay. And of course, one of the core themes you're going to find in today's talk is that everything needs to be machine readable, right? If we're doing vulnerability management manually, we're doing it wrong. And so we have ways of conveying this in XML and in JSON today. There are 2 popular formats that are being deployed today, CycloneDX and SPDX. You want to learn more about them, Google them, get in touch. But how are we going to be using SBOM? So right here's the formal definition, which is it's a formal record containing details of supply chain relationships, various components used in building software. Now, SBOM is something that can contribute to the entire life cycle of software. And I want to be clear. Very few people have ever claimed that SBOM will solve all of our problems. In fact, one could argue that by itself, SBOM may not solve any of our problems. But what it does do is it creates a common data layer that can inform how we produce software, how we choose software, buy software, and then how we operate software. And I would say it's very difficult to have an SDLC, a secure development lifecycle, if you aren't tracking your components. It's very difficult to responsibly select which software you're going to be running on your network or going to be using in your product if you can't see what the dependencies are. And of course, how do you do vulnerability management if you don't know not just is there vulnerability in this product, but in any of the components as well. And in fact, there's some language to describe exactly what these use cases are in the president's recent executive order. So we're going to see this more and more problem, a bigger part of how we think about software. But
Allan, stop. This talk shouldn't be about SBOM. Sorry for that, but you wanted to talk about vulnerabilities.
It's true, and forgive me, those of you who know me know that once you get me started talking about SBOM, that's what we're going to talk about, because there is a very important link to sort of tie in how SBOMs relate to vulnerabilities, right? Because we have all of these things out there. Every month they're going to find more. Of course, the coming few days, we're going to see a lot of great talks by some really cool hackers about all the great vulnerabilities they've found. We're never going to run out of vulnerabilities. The thing to acknowledge is we need to think about them from a data perspective, from an operational perspective. So how do we communicate vulnerabilities? We actually have a solid data layer today. Now, it's not perfect, but CVE, Common Vulnerability Enumeration, allows us to have that first level of data, which is to say, when I talk about a vulnerability and you talk about a vulnerability, we know we're talking about the same one. So is it perfect? Well, it's better than nothing. But I don't know, Jens, do you have any opinions on the efficacy of CVE?
Absolutely. So if there's a CVE, it's great. But there are a lot of vulnerabilities which don't get CVEs, or vulnerabilities which get silently fixed by the vendor and they don't request a CVE. So what about these? And how to track these and what to do about it?
So it sounds like it's really hard to actually build a soup to nuts management program just based on this. It's better than nothing, but we need to do better. And
absolutely. And from the point of an end user, you need security advisories. You don't need the vulnerability, because as an end user, okay, there's a vulnerability in library XY, but how do you act on it? And you need a security advisory.
It's true. If just having a number doesn't magically fix things, we need to know what to do about them. And there's another core point here, which is that not all vulnerabilities are actually exploitable. So, for example, everyone loves to talk about Heartbleed. Depending on how you measure it, OpenSSL 1.0.1 has between 600 and 1,000 different function calls you can make. 2 of them call the code that has the heartbeat function, which allowed reading a random memory from an internet-facing device, which was the Heartbleed vulnerability. So someone who's using that could just say, hey, you know what? I'm just using, I don't know, the PRNG. I don't know why you use that PRNG, but I'm just using that chunk. So the code isn't there. And in fact, there's some estimates from vendors that have said actually for using vulnerable components in downstream products, a small minority of those products are actually affected. Does that mean that it's totally okay to use vulnerable components? No, still something that we need to pay attention to, because even if it's 10%, well, that 10% is going to get you. And so what we need to do and what the approach is as we're thinking about SBOM and vulnerabilities is to understand how we can think about and communicate whether or not a vulnerability is actually putting something at risk. We need a way to communicate that this product is not affected by this vulnerability. So I'll give you an example of where someone's had to do this recently. The Zephyr project, which is a great real-time operating system platform developed by the Linux Foundation for IoT. It's a wonderful project. If you're in that world, check them out, help them out. They said, hey, this Amnesia 33 vulnerability, right, buried deep in the networking stack. It's a DNS bug that affected potentially hundreds of millions of devices. But the Zephyr team did the homework. They've got a good product, folks. They've got folks that think about security. And they said, we're not affected. Like, we heard about it. People said, hey, you're in the IoT space. Does this affect you? And they had to say, we are not affected by any of these vulnerabilities in any of the current releases or in any of the long-term support releases. And that's really important, right? That's something that their customers are going to want to find out. The challenge is that that doesn't scale that well. There's going to be some challenges because, right, if you're a manufacturer that uses Zephyr, you're probably using tens or dozens or maybe even hundreds of other components. And if you're an end customer with a factory floor, how many hundreds of suppliers do you have for this? So we need to have a way to make this scale, right? How many device types are on your factory floor? So one of the core challenges we're trying to get to that we're going to need to handle in a world with SBOMs, and remember, we're getting there, is how do we communicate that a device is not exploitable? And so allow me to introduce you to one of the most poorly named projects in all of InfoSec, the Vulnerability Exploitability Exchange, or VEX. Now, a couple of things I want to talk about first is let's saddle with the word exploitability in that it's used as a common part of cybersecurity policy, both at the policy people in global capitals, as well as how do I manage my system. But we've been around InfoSec long enough to know that that term is very loaded. And if you try to say, a particular vulnerability is never exploitable, well, you're going to run into trouble because, someone is going to be clever and figure out how to chain things together. So let's use the word affected. Not like, gosh, Allan, you're really affected, but does someone need to do anything? I, as the customer or the downstream user, is there anything that I need to do? And in fact, we can even define it formally, right? Actions are recommended to remediate or address this vulnerability. Now, this could be, learn more about it, right? The action could be, hey, you remember how we told you to definitely not plug this blinking box directly into an internet connection because bad things would happen? Could you please make sure that you listened to us when we told you that 3 years ago? Right? That is an action you have to take, so they might still be affected, even if it's, context dependent. Or it could be something as simple as apply a patch or tune your IDS or segment your network or something, right? There are lots of things that you can do to address or remediate a vulnerability. Now, the opposite of affected is, of course, not affected, which just means you're good. No action is taken. So that just means, here's a vulnerability, it's out there, but it doesn't affect our product. It doesn't affect this code. Now, there are a bunch of reasons why that could be, right? The vulnerability is not present, right? The compiler ripped it out. It's not exposed. I've got existing controls. My engineers are very good, so they sanitized all their inputs that were going into this function. That's fine, right? There are a bunch of ways, and in fact, we're slowly working on making that level machine readable. But in the meantime, simple trade-off of affected versus not affected. No change is necessary. So if we wanted to implement this, what will we need? Well, a couple of things. First, it needs to be machine readable and automatable. right? The goal here is to ultimately have this be part of our automated systems of thinking about this. So we need a couple of details. We need descriptive data, right? Tell me about the software in question. And then the vulnerability status, right? Is it affected or is it not affected? And then as much information as you can give me to help me make a decision. Not all of it's going to be machine readable at the beginning, but enough of it is, especially being able to point and map to a piece of software and then having the vulnerability status. So high level, required fields for what we're looking for is the metadata, right? Where did this data come from? What is this VEX file? And then a product ID, right? This is referring to Zephyr or this blinking box by this manufacturer. And then some way of tying it to a vulnerability. So what's the vulnerability ID? And then what's the product status? So, right, is it affected or not affected? That's its core. Now, all of this kind of sounds familiar, doesn't it, Jens?
Absolutely. It sounds like a security advisory.
You're damn right it does. Now, again, when we talk about security advisories, those are not traditionally machine readable, right? Some of you have seen them. It might look like this, or like this, or like this, or like these, right? These are complicated and messy. And by the way, what we're proposing is not a traditional security advisory, but a negative security advisory, right? The goal here, the whole idea of VEX, is to say, I am not vulnerable, which is right, the opposite of how this works. But there's no reason why we can't have those, especially if we can automate them. And besides, how hard can security advisories be?
Very hard, very, very hard, because my team is tasked with reading them and processing them and determining if critical infrastructures in Germany are affected by them and issue warnings and do a lot of stuff around them. And currently, we are already swamped with security advisories. They are correlated to the number of CVEs. We don't have proper figures which go back for such a long time, but they are correlated to CVEs. And you see the more or less exponential growth. And about exponential growth, we learned something about the last year. So it's not a good sign.
And I think, by the way, it's pretty impressive that we don't even know how many security advisories there are. CVEs are at least a little centralized. There's no centralization here.
Absolutely. And there's also no automation. So my people scrape the websites, and some of them are support portals, some of them are behind logins, and they're very difficult to automate. And we took 3 advisories, for example, one from CISA, one from Schneider, and one from, I think, Siemens, and they're all in different formats. So one is HTML, PDF, and you see everything. You also, a support portal, try to automate this. It's very, very hard. And they are machine readable? No, they are human readable. They are designed to be read by humans. And their structure is different, their language is different, and it's very, very hard. And if we look at the timeline, so there is a security researcher internal, somehow a vendor becomes aware of a vulnerability. He analyzes it, finds, okay, correct, and they release a patch and an advisory. And what we are trying to address is the time till the asset owner does something. At the moment, vendors who take good care release their patches and advisories, and vendors and asset owners, it takes far too long to reach them and for them to act. And there are so many, for example, when we had the exchange vulnerability, we tried to address them, and it took ages for the operators to react. And we need to automate it. And there comes CSAF into play. And with CSAF, the Common Security Advisory Framework, well, at first it's a standard. It's a standard which defines a JSON format machine readable file or system. It's not only a file, it's a complete ecosystem. And if you have ever dealt with security advisories and automation, you might have known Common Vulnerability Reporting Framework, and this is the successor to it. And this is what we're trying to push forward.
And why is it? Why are you guys doing this in Oasis?
Oasis it's historically based or situated in Oasis Open, and I convinced my management that it's something we need to do because we are tasked by law to assess the impact of vulnerabilities on critical infrastructures, and therefore we read the advisories because we can't determine, because we don't have an SBOM, if a product is actually vulnerable. So we need to read the advisories and have to rely on them, and therefore that's the only way we might solve this issue, or we hope to solve this issue. And by the way, there are big companies contributing or working in the development of CSAF. And I personally got into this because a colleague from Siemens, we met at a PCERT meeting, and he told me, Jens, we're doing the best we can, but our advisories are not reaching the customer. What can you do? What can the government do to get it to the customer and to reduce this time to react? And then we delved into this, and we found that there is already CSAF in the making, and a colleague in my team, he really pushed it forward, and we made a lot of progress within the last year.
And I should also add that your colleague Thomas has gotten me involved. He called me one evening. I was on my exercise bicycle, and somehow that turned into a 45-minute conversation where he told me and convinced me that this is a great project. So it's something. It's why the U.S. and German governments are giving this presentation together.
That's right. That's right. And to walk you through the whole process, what is done today and why it is so painful. We, at the moment, the vendor produces a machine-readable advisory, as you saw, PDF, text, whatsoever, and then he publishes it. And there are usually, or often, there are several CVEs and several vulnerability scores there, and often 10, 20, no worries. Then the user has to search for it. Has to be, he might be subscribed to an RSS feed, he might get a notification via mail. Sometimes it's only in a support portal where you get no notification, then you have to download it, and you have to read them. You have to read all these advisories, and that's what part of my team is doing every day, just go through these advisories and sort them according to criticality, according to how the impact of these vulnerabilities, of the fixed vulnerabilities, might be if they are not addressed. And we are prioritizing, and after the prioritizing, a customer, an operator, an end user would have to look, okay, now I have these advisories. Do I have affected devices? Am I affected? And then if I'm affected, so I have to do a risk assessment. So should I patch, when we think about Art Mannion, and should I patch now? Should I patch in the next cycle? Or should I accept the risk? These are the three options you can take, and they're nothing more. You have three options, but determining which of these three to take is extremely difficult. And if we automate it, we will benefit hugely. We expect a huge benefit for the whole community. And if we look into a CSAF document, it's a simple JSON file. It's a simple JSON file. Put one up. It's not rocket science. It's the thoughts which went into this were quite extensively. And Thomas did a great job doing that, and really creating this ecosystem around it, not only a JSON file, but a lot of different things like VEX. And now I want to show you when we automate it. So now we have machine readable advisories, and they're being published. And then the search for new updated advisories and the download will be automated. And because we will get a repository and a system around it where to find advisories on the websites and thinking about where to download them. And then the evaluation phase starts. So do you have affected devices? This can also be automated, because now you can have a magic algorithm which says, okay, I have this type of system, this advisory, okay, they match, so I have to look into these. But you can reduce the number of advisories you have to read quite heavily. In theory, it would be best not to have to do anything, but well, you reduce your workload quite extensively. And you can also do some kind of some help how to act on the. If you have you could, for example, put Mitre attack framework into this and throw this in the Mitre attack framework, and now see how your system reacts. Or you could do something like a digital twin, where you have these advisories. What's the effect on your systems which are affected? It's everything. Everybody talks about how to act on these advisories, but nobody talks about the input data. And this is the time frame or the timeline we just talked about. And if we would switch to CSAF, it would not work at the moment, because the vendor would need a content management system, some system to manage their advisories. Although we have this standard and it will be published soon, probably next month, the asset owner needs an asset inventory. And asset inventory on the asset owner side is something which is still not perfect. Let me put it this way. And then we need some magic algorithm to fit these two together. And this will be the next challenge.
And by the way, on the asset management side, it's one of those things that, people can innovate and make as many cool new tools and widgets as possible. But at the end of the day, the basics are still there, right? All of what we're talking about says we still assume that there has to be a certain amount of minimum competence for building out the asset management side of things.
Absolutely. So if we think, I want to sum up the benefits of CSAF. So I hope I will gain a few people from, I don't need to burn good technicians, people with good technical experience and skills by just reading these files. And on the asset owner side as well, so you need a skilled person to read and to act, and you don't need them anymore. They can do better work. They can do the work they probably not so boring work. And you could even externalize it. You can give it to a third party. There's the asset inventory. Inform me when something's going, when we are affected. And you don't have to read so much. So it's scalable, even across many vendors, because it's one system. And they don't use different formats anymore. And as I said, basic risk management is also much better. Well, and now a little bit about SBOM and supply chain. So if we think about the chain, so every supplier is also a user of a product and a vendor. So
this is, I love the line. Oh, I was just going to chime in and say that everyone is in the supply chain, and most of us are in the middle, right? Most of us, very few of us are only operators, but most of us who touch anything related to product are using things from someone and then are sending things downstream to others.
Absolutely, and this is so. If there's some open source library which is affected, and you use this open source library in your product, then you are already in the middle. And this is, and we want to reduce the time frame where products are vulnerable. And this is the same for the operator, for the vendor as for the operator, for the end user. If you are doing due diligence, if you want to do proper work, you have to implement this. Because as I said, most vendors are also suppliers. It goes around, it's a recursion. And for suppliers, there are also benefits, because who is doing that? There are software products which try to do this based on CVEs, but then again, without VEX, without a system that tells you that this CVE does not impact the product, you have to do a lot of work just to find out, oh no, I don't need to do anything. So it's the same here if you are a vendor as well. And I probably took a slide from Allan because I wanted to ask you, what does this mean for VEX?
Well, so I think there's as you were saying, there's a lot of value here for reducing human load. And right, the whole vision here is that it should be scaling. And as we think about risk assessment, this is only going to work if we can actually make this machine automatable and help people use the SBOM to focus on what we should be prioritizing, right? If a vulnerability is, if there's a vulnerable component in my supply chain, but my product is not actually vulnerable, then no one should care, right? We need to sort of be able to cross that off our list as quickly as possible. So how are we doing this in the VEX side of things? First, VEX is going to be a profile in CSAF. Now, for those of you who don't live in the standards world, profile is just a way of taking a big messy standard and saying, the stuff you care about, it's only this stuff over here, so you can ignore everything else in the short run. So that's a profile, just allows us to say, use these fields and you can ignore the rest of it for the same time, but at the same time, it's still part of the CSAF standard, so it can be integrated into the tooling. It also allows us to use the infrastructure and the systems that Jens was talking about. This is true at the folks who are creating CSAF documents, and Jens is going to talk a little bit about how to create them in a moment, and also ultimately down to the consumption. Now, this has a lot in common with SBOM, and some of you have heard me talk about how SBOM is a chicken and egg problem, right? And this is true for the advisory side of things, and indeed, everything in security where we're trying to help data move more effectively across organizational barriers is, no one's asking for it, so no one's supplying it. No one's supplying it, so no one's asking for it. So how do we prime the pump? Well, that's one of the reasons government got involved. For VEX and SBOM, the important thing is that we don't necessarily need to staple VEX into SBOM. They can be separate, but the important thing is they should be mappable, so that I can, when I get an SBOM, can say, all right, let me go and see if there is a VEX document that applies to this. So I can go and find out, okay, my automatic dashboard is blinking heartbleed, heartbleed, heartbleed. Let me go find and see if there's a VEX out there. And again, using automated tools so that I can now turn it off. And so I think that's really the power here is VEX complements and supports SBOM and continues to follow that model of machine readability. Now, how is this going to be implemented? Well, first, right, there has to be a product security team. So, right, the good little product security team is actually doing their homework to determine whether or not it's affected, whether or not a vulnerability affects them. Now, that's something they should be doing anyway. And this is one of those components where, on one hand, for those who are sort of a little uncertain, say, well, what if there's a terrible product security team? Well, we can't help you with terrible product security teams. But what we can do is create some very real incentives to help the team that is doing a good job be rewarded. And the story is pretty straightforward, which is to say, whenever, and some of you are in product security, you know this, whenever a new vulnerability comes out, good customers who are very worried, haven't heard anything, or maybe they just don't know where on the website to check, they're going to call you, right? Customer support costs skyrocket whenever there's a major vulnerability, even for things that are not related. So I've talked to the head of product security for one of the major switch manufacturers, and whenever a different switch manufacturer has a public widespread vulnerability, his team gets overwhelmed with calls saying, are you affected? I'm like, no, that's the other guy. The whole point is, so we can imagine having this automation as a way of saving a lot of cost. And so that means that if you put the money into building a good product security team that can do the quick turnaround of saying, let's find out quickly if our customers are affected, now you can actually through the power of automation, make sure your customers know this quickly, easily, in a fashion that will help them do their job better. So that is actually turning this into real dollars and cents. Now, the other thing to note is where are these VEX documents going to come from? The most obvious place is the supplier, right? Large manufacturer, software supplier, open source project, anyone can write, or right, the supplier makes the most sense because they're the ones who are the most familiar with this. But it's also important to note that they don't have to. One of the core fields is the author of the data. And just as today, you see folks in threat intel sharing lots of information about attacks that weren't necessarily related to their products. Similarly, I think we're going to see VEX documents written by experts in the field. So, right, maybe medical devices will focus on saying, okay, yeah, we're going to just affirmatively say, we're going to tell our customers that, these products are affected or these manufacturers aren't affected. Because again, sometimes it's actually quite easy to prove the negative. If you know that a certain open source library isn't used in a piece of software, then you can easily tell everyone to not worry about it. So the other fun thing that I can imagine is as people start to use this as a claim, who's going to trust them? Well, sometimes you have a long-standing relationship or you know the team, you trust your supplier. But another thing that I can imagine is happening is you're going to see bug bounties, right? This is literally putting your money on the line saying, we are going to pay a particularly large bounty if it turns out we were wrong. And so now you're going to basically draw a lot of attention to this as a way of validating this. So I think that's a really fun way this can do it. But also I want to acknowledge that this isn't just talk, right? This isn't just people in hotel rooms or Zoom calls building a standard. Folks are starting to implement this today. I mentioned medical devices. Some of you know that the medical device community has actually been leading the way globally on SBOM and supply chain transparency. They've been doing it despite the fact that the medical device community has been a little busy over the last 2 years, making things like respirators and working with hospitals that are busy trying to save all of our lives. And so, but this has been a priority. And in addition to producing SBOMs, medical device manufacturers are now starting to produce VEX documents that are being built to communicate to their customers whether or not they are explicitly affected by a vulnerability. So it's really great to see this out in the world. Now, if that wasn't enough, your friends in the government are here to help. Some of you may have heard of this administration's most recent cybersecurity executive order in the United States called Improving the Nation's Cybersecurity, or 14028, for those of you who want to be in the know with all those hip cyber policy types. And there's a great line from the introduction of this executive order that says, the trust we place in our digital infrastructure should be proportional to how trustworthy and transparent that infrastructure is. And so this is one of the reasons that people are even now more excited about SBOM than they used to be. It wasn't just because we've got really cool new SBOM stickers, but it defines SBOM and identifies the value proposition. I threw up some of that language earlier in the talk. But it also required the Department of Commerce to define the minimum elements, and ultimately it's going to require the U.S. government to define some rules, decide some guidance to make sure that everything the U.S. government buys comes with an SBOM. And I'll give you a hint. The U.S. government buys a lot of software, and so I think this is going to have a real impact. And in fact, if you look at this report that the White House gave a certain small organization 60 days to write, that's why my June was a lot of fun, it explicitly calls out VEX. And explicitly calls out CSAF as well as an implementation approach. So we are going to see this not just being an academic exercise, an intellectual exercise, but this really is something that folks are starting to build to today. So, problem solved, right? Well, not quite. We're still going to need some of your help to make this work. And one thing where I think there's a lot of opportunity for the BScience Las Vegas community is to build things, right? It's one thing to talk about stuff. That's what I get paid to do, is talk about stuff and help other people to talk about stuff. But standardization, I gotta admit, not the most exciting thing in the world, right? You can have a standard all you want, but if no one's building something, who cares? So we need tools. And so there's some really cool, interesting open source projects that are just starting. but there's tons of room for startups or for people who are looking to build their own project or to work on very new projects. I think this is going to be a very rich opportunity for folks to show leadership and either build an open source project or start a company or lean in heavily for your security startup. Jens, are there a couple of ongoing open source stuff that you want to flag?
Yeah, absolutely. So working for the government means you have no intention of getting rich, but you can do cool programs. And we have at the moment 3 of them running. SecVisogram is already finished. It's like Vulnogram, which is used for calculating CVSS score. And SecVisogram is a tool for generating CSAF documents. I will show, the next slide will show it, but we have more in the pipeline. A validator, which will check if a CSAF document is valid and even give you some additional remarks about usability and readability. And the domain checker is if you're searching for a company, if they are already participating, and checks if they fulfill several requirements for generating CSAF documents. So we have a lot. These 3 are in the pipeline, and SecVisogram is currently used for checking checking the standard, for expanding the standard, and it has. It's like Vulnogram. It's completely written in JavaScript. You don't have to install anything. You can download it at GitHub. You can run it there. You can test it at SecVisogram GitHub.io. And the usability is horrible. So it works, and it is a proof of concept, but I wouldn't recommend using it at the moment because it's there. Yeah, it's a proof of concept. And it generates valid CSAF documents, and you have also a JSON editor where you can enter code, and it checks everything. And it's nice, it's okay, but it's not for official use. So when there was this Amnesia 33 case, we dealt with them, and we covered the German companies, and we contacted them which were affected, and most of them had never written a security advisory. Never ever. They were completely hit by it, and we were a bit angry that we didn't have SecVisogram at that time all finished, because we wanted to give them, we don't want to show them how to, or we wanted to give them just a guideline, governments publish documents, and not really take their hand and walk them through every time. And there were, 40 cases we managed, or 40 vendors we managed, and it was too much. And SecVisogram would have been a great help.
And so for folks that are looking to get involved, or maybe some students or some young people that actually want to get their hands dirty on code in a real project, this is exactly the kind of thing that would be great, helping us take this and turn it into something that scales, has a little more user interface friendliness, a little more applicability, walks through a bunch of use cases.
Absolutely. So, yeah, you have to do something, and so what should we be focusing on? What's some takeaways? So now that we're sort of wrapping up our talk, what are some of the things, Jens, that you think folks who are listening should remember from what we've just said, other than the fact that we really lean heavily into the really graphics? So we still have the chicken and egg problem. It's still not solved. So if nobody asks for CSAF, CSAF won't fly. And we are pushing hard towards it, and we are working together with other governments in Europe to get it to fly. But still, we need more commitment from other countries. This would be something great. If you are already a supplier, a vendor, use CSAF. Prepare for using CSAF. So we have the two major automation companies from the not standard IT, but which are producing. I wouldn't say, I don't like OT so much because it's so keyed, but it's the companies who produce PLC, who produce RTUs, devices which are used in the field. And we have two major companies which are already committed to switching to CSAF. But that's still not enough, in my opinion. But we try to enforce it with legislation. This is the NLF. We will try if we can snuggle it in. At the moment, it's not there, but we will try, because how can a vendor prove that they are doing due diligence? And providing CSAF documents is one way of showing that. Another way could be certification and stuff, but hey, I'm using CSAF. This is the quality logo.
And I should add that it's probably a lot easier to start using CSAF than it is to get certified and tested.
Absolutely. You just put them out and say, we're using CSAF. And at least at the moment, it's an advantage. And it's not rocket science. Again, it has a limited number of required fields and a lot of optional fields. And the one problem with CVRF was that the field definition was not specific, and some between different vendors used the fields differently, and it was not so machine readable as it was expected. And we hope that for CSAF we did a much better job here. And again, spread the word and talk about it. Then we will come further and make progress.
I think that is a great mantra from the I Am The Cavalry world that I love to quote, which is, alone we can go fast, but together we can go far. And so let's, what's the big picture? So we know that the number of vulnerabilities is rising, it's going to grow, it's going to get even higher in safety critical world, whether it's automotive or medical or industrial. And we know that there's going to be better insights into the supply chain, right, as we have more visibility into this. And what is that going to mean? That's going to mean more advisories. Those advisories have to be machine readable. There's simply no other way for anyone to get their handle on it, whether it's the government or whether it's the companies that are trying to deliver services that we all depend on. And so we need advisories for good risk-based decisions. We need scalability. And I love the framing, which is like, what we're trying to do is automate the boring stuff. At the end of the day, a lot of security is going to require smart people to make decisions, but let's give them the interesting stuff and the critical stuff and automate all of the stuff that we can have. And finally, publishing known, not affected, right? Just being able to say, help communicate, this isn't a problem. Let's take stuff off of our plates. So we have some time for questions, some constructive criticism if you have it. And here's how folks can get in touch with us. That's how to find more information on CSAF and on VEX and, of course, on SBOM. And this is how you can get in touch with us. And Jens has helpfully included Thomas's information as well. So thanks so much for your time today. And we'd love to hear your questions and would love to stay in touch.
Please call us. And if you have a vulnerability affecting a German product, you can call us as well if the vendor is not responsive, by the way. Thank you.
Thank you.